Inference about two means. Lesson objective: construct and interpret confidence intervals regarding the difference of two independent means. Lesson objective: a simple random size of size n1 is taken from a population with unknown mean mu1 and unknown standard deviation sigma1. Also, a simple random sample size n2 is taken from a population with unknown mean mu2 and unknown standard deviation sigma2. If the two populations are normally distributed, or if the sample sizes are sufficiently large, n1 greater than or equal to 30 and n2 greater than or equal to 30, a 1 minus alpha times 100% confidence interval about mu1 minus mu2 is given by the formula. We have our point estimate here for the difference, plus and minus our t alpha divided by 2 times our standard error for the difference. So this is the confidence interval for the difference of two means. Let's look at an example. Construct a 95% confidence interval about the difference between the population mean weight of state quarters versus the population mean weight of traditional quarters. If you recall from the last video, here's our raw data for state quarters and traditional. We're going to use these two data sets to construct a confidence interval for the mean difference. We have already verified the populations are approximately normal and there are no outliers by our probability plot and box plot. X bar of state quarters is 5.702 with a sample standard deviation of 0.0497, and X bar for traditional quarters was 5.6494 with a sample standard deviation of 0.0689. If we were doing this by hand from table 6 with an alpha level of 0.05 and 15 degrees of freedom, we get the 15 degrees of freedom because we take the smallest of n minus 1. We see that the table would give us 2.131. Now I suggest we use Minitab and StatCrunch to actually compute the confidence intervals. But by hand, if we take x bar of 1 minus x bar of 2 minus the t alpha divided by 2 times the standard deviation, we get 0.0086 for the low end and 0.0974 for the high end. By using technology, let's start with Minitab. To construct the confidence interval, we first go to Stat, Basic Statistics, to sample T. We select the raw data. First data set is state quarters, second data set is traditional. We go to Options, and what we do is we change the alternative from a greater than to a not equal to. This will produce the confidence interval. We hit OK and OK again, and in the session window we see the 95% confidence interval for the difference is given right here. Now it is a little different than what was produced by hand, and that has to relate to the degrees of freedom, which we'll talk about a little bit later. Let's look and see how we do this in StatCrunch. We go to Stat, T Statistics, to Sample, and we have Data. We select the data. State quarters is in sample 1, traditional is in sample 2. We want to make sure the pooled variances is clicked off. We select Next. We change it from a hypothesis test to a confidence interval, and we hit Calculate. Here we have our lower limit and our upper limit for the mean difference, and we can verify the information right up here. It's mu1 minus mu2 mean difference without pool variances. So why are we getting different values than we did by hand? Well, it has to do with our degrees of freedom. The by hand solutions will not equal the degrees of freedom in the technology unless we use this formula. So this formula here is what you'd have to use by hand just to get the degrees of freedom. I highly suggest you use Minitab or StatCrunch. So let's interpret this confidence interval. We are 95% confident that the mean weight difference of state quarters and traditional quarters is between 0.010 and 0.096 ounces. Now the question is what does this tell us? Since the confidence interval does not contain zero, zero is not in between the lower limit and the upper limit, we can conclude that state quarters weigh more than traditional quarters. Now what does that tell us? Well, that tells us that there is a statistically significant difference between the mean weights of these two. So anytime that we do a confidence interval for the difference of two means and zero is in the confidence interval, then we say that there is not a statistically significant difference between the two means. If we do a confidence interval and the confidence interval does not contain zero, then we say that there is a statistically significant difference between the two means. Thanks for watching.